the first stage of Vite really was like, let's just make things work and make it better than the status quo. But underneath, there might be a lot of hacks and things we want to improve in the future, and now it's the proper time to do it.
Hello, welcome to DevTools-fm. This is a podcast about developer tools and the people who make them. I'm Andrew, and this is my co-host, Justin.
Hey everyone, we're really excited to have Evan Yu joining us again. Evan, you were with us on episode 12 back a few years ago talking about Vue and Vite, and we are now like 119 as of recording, so over 100 episodes ago.
Wow, that's a lot of episodes.
We've been doing it a while, but it's so fantastic to have you back. We're continually big fans of your work and how it shapes the ecosystem. So excited to chat again. And we're going to talk about what you're up to these days. But before we dive into that, would you like to tell our listeners a little bit more about yourself?
Sure. Hi, I'm Evan. I have been an independent open source developer since 2016, and I worked on Vue. I still work on Vue. I work on Vite. And just recently we started a company called VoidZero and focus a bit even deeper that goes into, the full JavaScript tool chain, starting from servers, starting from parsers to linters, formatters, bundlers, transformers, everything that supports higher level tooling. So the bundler we're building called Rolldown is going to support Vite in the future. And Vite is now supporting a lot of other frameworks. So essentially, we're trying to build this vertical unified tool chain that can support all the frameworks that depend on Vite today and hopefully make everyone's development experience better.
So back on that old episode long ago, you had actually just released Vite. And since then, it's really become like a pillar of the industry. Like many a meta framework is based on it now, and it's like the starter pack for everything. What was the journey from going from Vite to, we actually have to rebuild most of what's below the surface level and form a company around that?
Yeah. I think the idea started at one point because when I first started Vite, I was just doing a prototype, honestly, right? So I pretty much just took whatever that's available out there and try to fulfill the goals. And there were a lot of trade-offs, and nowadays I consider them kind of hacks because I didn't have the bandwidth to do all the things myself. So I have to use what other people have built, and I think that's typically what we've been doing in the JavaScript ecosystem, because we feel like, okay, like we don't want to necessarily reinvent the wheels. Why not just use things people have already done? So in the beginning, I was using Rollup because I've always liked Rollup's API, and then we ran into performance issues because so the first step of Vite was to have a native ESM dev server, right? That sounds simple. And then we use Rollup to try to handle the dependencies, because some dependencies are in CJS. We want to convert them to ESM so they can load in the browser, but Rollup was actually quite slow if you have large dependencies. And so we started using ESBuild for that purpose. And then we tried using ESBuild for production bundling, and it was not satisfactory because it has no control over how the chunks are split. And the way ESBuild splits code is just a bit counterintuitive if you're building applications. So we're like, okay, now we need to think about, okay, we use ESBuild for development pre-bundling, but we use Rollup for production bundling. And we kind of smoothed over the surface to make them work kind of the same way, right? And later on, when people started building real applications with Vite, for example, when people are using Vite with React, and previously everyone was using Babel because Babel was supported. Interestingly, if you use Vite by default and you write JSX in TypeScript, they are transformed using ESBuild, which is quite fast. But the moment you want hot module replacement for React, Now you need to use Babel because ESBL does not support hot replacement and transforms. So but then Babel again made everything slow. So people also came up with an SWC version of the React plugin. So you see the problem here is there are great tools out there, but some of them do this, some of them do that. And on some of the things they both do, they decide to do them differently. And that's the reality that we're kind of dealing with in the JavaScript tooling ecosystem. I'm pretty sure it's like if you've worked with custom build stacks long enough, you understand what I'm saying, right? So in a lot of ways, the reason people love Vite is because we kind of hide this complexity away from them and try to, give you a very smooth and consistent entry point so that you don't need to think about these things. But we're kind of, for me, I think we achieved this goal with the initial version of Vite, but long-term wise, when people are starting putting more and more dependence on Vite, right? We've seen more and more frameworks moving over to use Vite as the base layer. I kind of start to worry because I feel like, the internal is not as pretty as you should be. And we kind of just swept all the deeper problems under the rug and pretend everything is great. So I guess deep down, you know, along with Vite's growth and adoption, I've always had this like inner urge to say like, is it really up to the task of being the future of all these like next generation frameworks is serving as the infrastructure? Will Vite be able to live up to that expectation? And I don't think it will if we just keep using this sort of fragmented internals and try to stitch things together and smooth over the inconsistency. So in a way, the toolchain we're building right now at VoidZero is an attempt to kind of attack this problem more fundamentally. Let's say like, if we want to solve all the problems we want to fix in Vite, what do we need? We need a bundler that actually is designed for it. And we need this bundler to be also built on top of a toolchain that can, handle all the different concerns, like starting from the AST all the way to minification and production bundling, right? Through a consistent system. And at the same time, we want to make each part of this toolchain individually usable. So let's say you want to just take the parser and do something crazy with it. You should be able to do that, right? This toolchain, although it's unified and it's a coherent system, it should not be a black box, right? You should not have to say like, you either take it all or you can never use it. So I think these are the two main premises that we're sort of centering the toolchain around is unification, but without sacrificing the ability of composability.
We'd like to stop and thank our sponsor for the week, Mux. If you haven't heard of Mux, Mux is an awesome platform that makes adding video to your product easy as adding a few libraries. If you've never had to add video to a product, you don't know how many pits of failure there are. Whether it's file formats, delivery, uploads, or even playback, there's so much to worry about and so much that will bog your team down while trying to ship a stellar product. So that's where Mux comes in. They have a set of APIs and components that make adding video playback to your app or platform super easy. And since there are a bunch of experts that know video inside and out, they'll have so many different features that your team would never have the time to get to. One of those things being metrics. They have all sorts of different fancy metric dashboards to understand how people are consuming video in the apps that you ship. Recently, they've been adding even more capabilities to their platform. Now you can see when viewers dropped from your videos, so you can gain better insight into how people are consuming those videos. So if you want to add video to your platform and you don't want to spend weeks to months doing it, head over to mux.com. And with that, let's get back to the episode.
So you've been a independent developer for a while, and probably one of the most successful, being able to work on a lot of open source projects and produce a lot of very successful open source projects while working mostly on your own. And now you're going this route of, so you've raised some VC, you're forming VoidZero, you have a few people coming to join you to like work on these ecosystem tooling. So why did you decide to make that transition from independent developer to starting a company? And like, what about the timing or the circumstances made this like a different choice?
So I think overall, I would actually consider myself a pretty risk-averse person. some of the biggest decisions I'd made in my life, I kind of feel like I just swinged it. But like going fully independent to work on Vue, I didn't really know what that would entail. Luckily, I think I've built a lifestyle entrepreneurship kind of lifestyle business thing around Vue, so that is enough to sort of support me and make my life sustainable. So on top of that, right, I'm not starting a company because like, oh, we need to make more money. So that situation. It's more about starting the company is the more realistic way to, essentially fulfill the vision that I'm trying to achieve. So it's also partly based on the experience of working as an independent developer. I kind of know where the limit of the current model can go. Um, I think a lot of people kind of use Vue and use me as a success story example for sustainability of independent projects. But at the same time, if you consider uh, the scale, the scope of Vue, like we have more than 2 million users supported by, I think at max, we had like 3 people working full time on Vue related stuff. Like now it's probably still around 3 people. That's actually full time on Vue, and then a bunch of part time contributors that we sponsor. So um, it's sustainable, but at the same time, we don't really see it growing, say, to the scale where we can have like a team of 10 people working on it full time, right? Because I intentionally try to build the business around Vue to be as passive and carefree as possible. That's a lifestyle choice. But also that means the conversion rate, because it's not a for-profit business. Like we don't do aggressive marketing, or we don't like push features to sort of drive profit or revenue. So in a lot of ways, the conversion rate compared to the user count of Vue is extremely low, right? And I'm not saying that's a bad thing. For me, there's no sort of this or that in terms of open source sustainability or monetization. I think it all comes down to the goal you're trying to achieve. For me, Vue is a lifestyle business thing, and I think that's working very, very well for me, right? I'm happy about that. But on the other hand, when I think about where Vite is going, and thinking about the potential that Vite has, and thinking about how we can actually, maximize that potential and make the thing, we hope it can be. And I don't see it happening with this sort of more passive model of like just hoping people donate, hoping people sponsor, or hoping someone comes up with a business and decide to donate back to Vite, right? That's actually has a lot to do with I think it partly with luck. It takes time. It also has a lot to do with what layer the project stands on. For example, because Vue is a very user-facing framework, so most of the income that's generated by Vue is due to the exposure, due to the high exposure and documentation. And because when people use frameworks, they would likely interact with the documentation very, very, very constantly. Build tools is quite different, right? It usually sits one layer below the framework. And also, when you set up build tools, once you get it working, you're happy with it, you rarely have to actually look at the docs every day. Right? So when we go even lower, say like we're building parsers and tool chains like that, I've seen how like projects like Babel struggle with funding despite such almost universal adoption across the ecosystem, right? So I don't think that model is going to work for the things we want to build. And but at the same time, this is quite an ambitious goal. So I can't imagine it being done with part-time efforts from just, contributors who are like, oh, we want to work on this together. I don't think that's going to happen, or at least it's not going to happen soon enough. So I think the only realistic way for us to actually do it is to have enough resource capital to have to get people paid properly to work on it full time and as a team, right? So we have a common mission, a common goal, and it's much more serious than your let's contribute to open source after work or on weekends, right? It's different. Um, So that also inevitably brings in the question like of expectations from investments and returns. And I think one of the other goals of starting a company is because I always felt like it's a bit sad that the JavaScript ecosystem is relying on a lot of critical infrastructure that's maintained by people that's either underpaid or just as labor of love, right? In a way, the ideal situation is we hope, okay, like big companies using these open source projects, making a lot of money, they should donate back, they should sponsor. Um, and I think it's difficult because there is so much logistics that you have to go through to actually set up the proper organization like a foundations and align the incentives. And there's a lot of lobbying, a lot of like just talking to people and getting people on the same page and to make things like that happen. And smaller open source project authors really don't have the leverage or the time and the energy to make that kind of things happen. Um, so, and it's uphill battle before you accidentally become kind of the critical infrastructure the entire ecosystem relies on, right? So, I think VoidZero is also a different attempt, where the end goal we hope is we have a sustainable business model that's mostly coming from bigger companies, enterprise that's paying money that allows us to keep improving these open source parts and keep it free and open source for individual users, for smaller companies, startups, so that more people have more JavaScript developers have free access to high quality tools. At the same time, the tools should also be well sustained and maintained.
So is your plan for monetization like charging bigger companies to use the tools and then like letting it be open source free for everybody else?
Not exactly. So we want to draw a line where if the code runs on your machine, it should be open source and free, right? We don't want to do things like. So one thing we definitely don't do is to like ship something as open source and change the license later and hope people pay for it. Right? That's just not the plan. The plan is likely to build. We do have plans on building associated services that's tied into each step of the way. Because when you have a toolchain, you have natural tie into a lot of metadata every step of the way. And how do you get deeper insights from these metadata? Uh, and how can we get higher quality metadata for each task you're performing on your code base, right? Overall, I think there's good opportunity to have to improve upon what we're currently doing. For example, like how much deeper insights can we get from our bundles? Like, is your tree shaking accidentally failing? Is your chunk cache invalidation working consistently? Are you bundling things that shouldn't really be in the production bundle? And is your code after your code is transformed by all these tools, is it still as secure as the source code pretends to be? Right? So there are a lot of questions uh, that's hard to answer if you don't actually own the toolchain and be able to look at the source code from start all the way back, all the way to minified in production that you actually ship to the users. Um, so I think there's quite a bit of opportunity here, and we're intended to essentially build services that's centered around this space. I can't do. I don't want to be too specific right now because there's obviously a lot of things that can change. There's obviously some details we're still working on, but the idea here is there will be if we make money, it's from services. It's not going to be from the open source stuff that we built directly. And the open source tooling obviously serves as the funnel and the moat for the services that we built, and that's the ideal outcome.
I think that makes a lot of sense. There is this like real thing of like big companies using open source tooling. It usually doesn't scale super well. And if you've worked in a semi-large company and you've used Webpack, for example, and you know like, oh, we have like a 5 to 10 minute Webpack build. Well, like most people don't experience that because their apps are too small. But like if you're a really
Mhm.
large organization and you're bundling a lot of
Yep.
code and you're like running a lot of transforms and you're doing a lot of custom stuff, you start hitting in those things. So I like think it makes sense to a large degree to say, hey, you've just got more needs and we have tools to sort of solve those needs. Whereas, 80% of people won't ever hit that scaling point.
Totally. Yeah. One a part of the reasons we believe there's a market for this is because half the team is have worked at ByteDance on their web infra team, and they support some of the largest scale JavaScript applications that we have ever heard of in the industry. And some code bases with 100,000 lines of JavaScript code, and takes half an hour to build. Um, so scale that not every developer would have to ever deal with, and but that's why a lot of the tools that we are building, like the starting from the OSC parser, is like we are obsessed with the highest level of performance, so that these tools can still handle the scale. The biggest scale application you can throw at it, it should be able to still do it with decent development experience.
So speaking of the OXC parser, I kind of find it funny that it seems like that project in Vite itself started in the same way, where like you were just creating a thing to for a side project, and I think Boshin, the guy behind OXC, was just kind of
Hmm.
creating a reference implementation of a parser in Rust. So how do we get from
Yep.
there
Yep.
to this is now like that one little Lego block at the bottom of the big structure that is VoidZero?
Yeah, I think a lot of it is me when I was thinking about, okay, we need to write our own bundler for Vite, and what do we base the bundler on top of? And we looked at, so there are multiple ways of thinking about this, right? So rewriting JavaScript, no, because it's going to be too slow. So we want to do it in a compiled to native language, and we looked at Go. There's already ES build, which is a great project. I think the downside of ES Build is, in order to achieve the maximum performance, ES Build is architected in a way where many different concerns are layered across as few AST passes as possible. So it's like its minification logic is actually spread across multiple passes. Uh, and it's not like minification is minification. It's like in the same AST pass, you would see some branches dealing with minification, some branches dealing with transforms, and that making external contribute, making like basically extending ES build in a reasonable way quite difficult, because you're going to be adding more branches in these AST paths, and it's going to be very difficult for us to manage it. Like Evan Wallace is obviously brilliant, and he has everything in his brain, and he can sort of improve ES build with this architecture because that's his intentional decision. But we just feel like it's not a good foundation for us to, if we want to ever extend on top of it. And also, we do want to make each part sort of well isolated so that people can use it as individual dependencies instead of having to opt into the whole thing all at once. Um, so then we turn to Rust. And so Fortune actually also contributed to RS Pack at ByteDance. And there are some technical decisions in RS Pack that made it essentially too late for them to switch to OXC. Um, because it's already kind of built on top of SFC for a very long time before RxC was even usable. Um, but I have been keeping an eye on RxC for a very long time, and I think it is important that for the new tool chain to be based on something that kind of learns from a lot of the things that we've done in the past, because it's when Borschen worked on OXC, he had contributed to Rome/Biome in the past as well. Uh, they had to contribute to SWC and deal with SWC during our spec development as well. So the team at Web Infra has a lot of experience dealing with, Rust language toolchains and systems. And I think he distilled a lot of the learnings into the development of OXC initially as a proof of concept. And when it became a bit more production ready, it showed that, okay, all these things did pay off. Like both SWC and OXC are written in Rust, but there's a pretty significant performance advantage that OXC has. And there are some other design decisions that's a bit more detail. For example, when using this language toolchain to support the bundler, there are a lot of semantic analysis that we have to do. For example, like determining whether this variable is referenced in this current scope, or is it shadowing the outer variable, or is it used and exported by and use another module. A lot of these kind of things, you have to do the analyzation, right? So in JavaScript, most of the parsers just like stops at giving you the AST and they're done. So when we are dealing with, say, I think Babel probably provides a bit more infrastructure for that. But in my own work, for example, in the Vue compiler, we have to do a lot of these semantics analysis ourselves. I think in Svelte, Rich Harris has also written quite a few tools centered around this. But I believe that should be a first-party concern of a language toolchain. So OXE actually comes with a semantic analysis API that allows you to query these information after the parsing is done. Because as you parse, it also collects and stores this information already. So you don't have to do the traversal yourself to figure out this information. You can just ask, right? So this is also slightly different from, say, the way SWC works. In a way, like I don't want to bash SWC because it is the first JavaScript Rust toolchain, right? And I think it served its purpose really, really well. A lot of people are still using it. It's great. But I think there are things we can learn from it, learn from the past efforts. And we believe OXC is just a better foundation if we want to build more ambitious features on top of it. So Rolldown essentially started out with OXC as the base, and so far we are happy that the performance is turning out to be living up to our expectations.
Something I've always admired about your approach to projects is that very iterative style. So I remember when I first discovered Vue, you were just making the transition from Vue 1 to Vue 2, introducing virtual DOM, learning a lot of lessons from React. And that always struck me, and I feel like you've sort of had a pattern of doing that over the years. So I'm curious to like tie into the sort of incremental approach that you're taking now. What have you learned from projects like Biome and Rome, for example, who have tried to tackle somewhat similar problems, but maybe from a different angle? And SWC probably is like in this same category. They're like trying to tackle some performance problems. What are the like big lessons and takeaways and things that you're trying to do differently than those projects might have tackled?
I think in terms of the end vision, it's very obvious that VoidZero has a lot of similarity to what Rome wanted to do. I think there are two major differences. First is we decided to work on the toolchain for VoidZero, mostly because we already have Vite serving as sort of a point of convergence, right? If we don't have Vite as the leverage, then the chance of success will be much slimmer, right? And Rome really didn't have anything like that. They started out with something that's completely from scratch, and with the hope of so for Rome, I think the biggest challenge is just going from 0 to 1. How do you make people adopt it, right? And they started out with a formatter, which kind of makes sense because formatter is probably the least intrusive piece of task that's in the overall development flow. In a way, it's completely coupled from everything else. That makes it easier for people to switch to and adopt. The downside of that is it's also not a strong, leverage to have because it's not really related to the rest of the tasks people are doing, right? So I think the angle where you get the adoption from, this is more like a strategic difference, I think, right? Another more technical difference is, I think Rome's implementation or Biome's Rust code base was initially designed to be more intended for an IDE use case scenario. Like they focused a lot on the IDE story. So they essentially built something, they use something called CST, concrete syntax tree, because they want to preserve the shape of the original code as much as possible, and they want to be resumable and more error resilient. A lot of this are great for IDE use cases, but not necessarily best if you want to do the other tasks, for example, get the fastest possible transforms, and also basically be able to use the AST for multiple tasks along a long pipeline. So I think Ocean could probably share more insights on this front, but I think the difference between the AST and CST was also a major reason where Ocean was like, we don't really want to do that in OXC. Yeah, but I think it's unfortunate that Rome didn't get to actually, keep going beyond what it is now. But I think it still showed people that it's possible to write high quality tooling for JavaScript in Rust, because a lot of people are happy with Biome as a formatter nowadays. And it's also part of the reason why we're not in a hurry to work on formatter, because it already kind of fills that gap. We will probably eventually have an OXE based formatter just for complete sake, but for us, that's just going to be down the road.
Your first point reminds me of the saying, make it work, make it right, or make it work, make it right, make it fast. Like, you made it work. Vite, we already have like the grand vision, and just all of this work now is like truly like making it right and being able to like make sure the pipes make it fast.
Yeah, in a lot of ways. I think the first stage of Vite really was like, let's just make things work and make it better than the status quo. But underneath, there might be a lot of hacks and things we want to improve in the future, and now it's the proper time to do it.
So I've developed a little bit of a few Vite plugins as I've gone along. I've done a lot of static site generation, and I've rebuilt Storybook a few different times. And most of those things usually come down to like, I need to make a very intense plugin for the system. And the one thing that kind of trips me up a lot of the time is the plugin API for Vite is the same as Rollup, but it only has like a select few hooks. And I feel like those hooks are probably excluded because like we have like speed concerns in the mix. With the advent of like Rolldown, will we see the plugin API start to like open up a little bit? Like, will the speed unlock more power that we can give to plugin devs?
I'm curious, what are the hooks you were looking for but doesn't work in Vite?
There's just like like 4 or 5 of them that like I've always want to use, but they just don't run in dev mode because they're not there. So yeah, just wondering, will the new power expand to more stuff for us to do?
So it's this is an interesting one because so first of all, with Rolldown and in a future version of Vite, dev and prod will become more consistent. They will be using the same plugin pipeline, and the plugins will work exactly the same between dev and prod. But the interesting part about having JavaScript plugins running in a Rust-based tool is there is the overhead of sending data back and forth between the two languages because they don't share memory by default. So in most cases, when you send things across the wire, you have to clone them in memory. And that's probably one of the biggest bottleneck for speed. So let's say if you use raw Rolldown without any JavaScript plugins to bundle 20,000 modules, it can do it in 600 milliseconds. But if you add a couple JavaScript plugins, you can slow it down by maybe 2 to 3 times. And this is directly correlated to the number of modules because we have to, for every hook of every plugin, you have to call it once for every module. So let's say you have a plugin with 3 hooks, then we're doing 60,000 Rust to JS calls. And that's not cheap. Even if you don't do anything in a hook, it's still quite a bit of a cost, right? So we're looking for ways to optimize that. So first of all, base layer compatibility is we want all the existing Vite plugins to be able to continue to work the same way. It might compromise the ideal performance to a certain extent, but let's make things work first, right? And then the next step is for Vite itself internally, we've actually already ported some of the Vite internal logic over to Rust. So right now it's only for for builds. So when you do the production build, you can enable the native equivalent of some Vite internal plugins. So that allows us to essentially get Vite build speed down to maybe 2 to 2.5 times slower than raw Rolldown without any JavaScript plugins, which I think is actually decent. And in fact, that's already kind of on par with other pure Rust bundlers. And then we are doing a few things to essentially, there are two different ways you can think about this. One is reduce unnecessary Rust2JS calls, right? So in typical Rust rollup plugins, we do a lot of things like in the transformer hook, we look at the ID. If the ID ends with a certain extension, we do this. Otherwise, we just return early. This is actually wasteful if you're using the plugin in a Rust bundler, because the bundler essentially does a Rust2JS call, figure out it actually doesn't need to do anything, but it already paid the cost, right? This is why ES-Builds plugin actually requires to have a filter outright before it is ever applied. And we're going to essentially introduce something similar. So it's going to be an extension on top of the current rollup syntax. It's going to be compatible because when you use the object format for your hooks, right? So you specify your logic in the handler property, and then you can have a filter property to say, only apply this hook if the ID matches this regex or something like that. So we can essentially determine whether this hook even needs to be called for a certain module before we even call it. So we don't even need to cross the Rust2JS bridge. That's one thing. The other thing is we're seeing a lot of plugins in the wild doing very similar things. For example, in the transform hook, a lot of plugins take the incoming source code, parse it using a JavaScript parser in the hook, and then do their own like semantic analysis or AST traversal, and then use something like magic string to alter the code and generate a new code, and also need to generate the source map and then pass it back to the bundler. So a lot of work done in JavaScript, not leveraging the Rust parts. And then also the Rust need to take the source map and do the source imagine. And source maps are also quite heavy to pass across the boundary because it's bigger objects than source code, right? So we're trying to design APIs to essentially make this kind of standard ASD-based simple transforms to be as efficient as possible. So imagine instead of getting the string of the code, you actually get the pre-parsed AST directly. And instead of manipulating the code and generating the source map in the JS side, you still do the same kind of magic string-like operations, say like append some code here, remove the code here. But these operations are kind of buffered and send as very compact instructions back to Rust. And the heavy lifting of code manipulation, string manipulation, and source map generation is actually done by Rust on the Rust side, right? So the only work you're doing on the JS side really is looking at the AST and record the operations you want to do, and then tell the Rust side to do it. So I think this, in fact, can cover a very wide range of custom transform needs, right? Because like we're actually able to build views, single file component transform entirely using this model in JavaScript, right? And if we get this API natively from the bundler, then we can actually offload a lot of the heavy lifting to the Rust toolchain instead of doing it in JavaScript. And I don't even need to install a parser dependency myself. So this is the second part of it. And then if we go a bit deeper, this is further down the line. We're also investigating whether it's possible to send ASTs from Rust to JavaScript as little memory cost as possible. So this is something called like zero cost AST transfer. Theoretically, it's already possible using a shared array buffer. And then we need a custom deserializer on the JavaScript side that understands the memory layout and be able to like lazily read the AST from the flat array buffer as you need. Right? One of our team members, Overlook Motel, actually has a proof of concept of this working already, but getting this properly into OXC is going to be quite challenging. So this is something we're eventually going to do down the road, but the proof of concept shows that this is possible, right? And there are some exciting things in the JavaScript specs. For example, there's a share structs proposal. That's quite new. That's still stage 1, but it also is, kind of exciting if you can use share structs to essentially properly share state across worker threads and maybe Rust, right? So what this unlocks is proper parallelization of JavaScript plugins. Right now, when you use JavaScript plugins with a Rust bundler, because the JavaScript plugin still runs a Node.js process, it's still single-threaded, right? One thing we've done is trying to use multiple worker threads to parallelize the workload. But the downside of this is, for example, if the plugin uses a heavy dependency like Babel, right? Each worker thread needs to initialize with Babel and allocate the memory for it. And in a lot of cases, it ends up the gain, is smaller than you might think. Like, because it's like the initializing cost of each worker thread just like offsets so much of the performance gains you get. It's challenging. Like, there are some things we played around with. For example, instead of spawning the worker threads through a Node.js main process and then kind of get the data back and then send it back to Rust, we let the worker threads directly send the data back to Rust. I think some of this might be useful, but applying them blindly for every plugin may not end up being as beneficial as we think. So there's still a lot of work that we're exploring in this area. But I'm kind of optimistic that, or a long-term goal for us is to tackle this, still allow users to easily write JavaScript plugins, but without severely compromising the overall performance of the system.
Yeah, I do think that this is one of the hardest areas for all the reasons you've outlined. And the temptation is real to just say, sorry, no more plugins in JavaScript. But like, it's also, there's a big ecosystem churn cost there, which is a pretty big downside.
Yeah, I kind of want to mention there's also we do want to start with getting the plugins work, right? Then we start having a recommended subset or a recommended best practice for writing performant JavaScript plugins for Rust. So maybe we'll have linked rules to help you kind of guide you writing these plugins, or we can have runtime warnings. Like, one thing we actually did is we use OXC to implement a small tool that can look at your plugin source code and it'll look at, for example, look at your transform hook and notice that you're doing something like if id.test regex return, right? So this is a sign of early return. It shows that this transform hook is actually eligible for filter optimization. We'll detect such cases and actually give you a soft recommendation, say like this plugin hook can be refactored to use the filter API to make it more performant.
So it kind of sounds like there's going to be kind of a divide here at some point where there's a bunch of legacy roll-up plugins that still work in the new architecture, but then as we go on, kind of like a recommended V2 of all of those that use these new APIs to make things really fast.
Yeah, and in a lot of ways, we do also want to make most of the common things you need to do built in. For example, if you use Rolldown today, you don't need CommonJS plugin because it just works out of the box. You don't need the Node Resolve plugin because it just works out of the box. You don't need TypeScript transforms. You don't need JSX transforms. All of these just work without plugins. So in a lot of ways, it's similar to Rollup's abstraction level is a Rolldown's abstraction model is a bit more like esbuild/Vite, right? It's a bit more battery included because that's also the most pragmatic way to get the best possible performance.
Yeah, it makes a lot of sense. I'm really interested to see what y'all end up coming up with the AST transforms, because I feel like this is a pretty common problem. Is like, if you need to do very performant AST transforms, I mean, you have the added problem of like going across language boundaries. This just reminds me of a random project that I saw the other day called like Render from this guy named Eric Mann, and it's like, it's a bytecode that runs in JavaScript that like is a rendering engine or whatever. And it's just like, I don't know. There's like a lot of interesting things in the space when you start thinking about like, how can we make like marshalling and serialization very, very, very fast. So this will be really cool. I'm excited. Well, maybe as we're getting close to wrapping up the episode, let's think about or talk a little bit about what the future looks like. So you're saying earlier that Vite is already pretty prolific, so it is your starting point. You have sort of this broad baseline that, say Rome when it was starting was missing, but there's still a lot of work to do. So What do you like think the priorities going into the project will be, and what is your like time horizon that you're sort of anticipating for say some of your first products when you release? Like, what does that look like for you?
Yeah, so this is obviously going to be a quite long process. I think right now our priority is getting Rolldown to sort of a beta status. There's a lot of alignment work that we need to do right now because with the goal of being able to swap out ESBuild and Rollup, right? We need to make sure, like, because the sort of the mission of Rolldown is to unify the two. So in terms of how they handle, for example, CJS, ESM, interop, how they handle a lot of the edge cases, uh, they need to be as consistent as possible. But we need to basically enable the test cases of both bundlers, run Rodan against those test cases, and try to pass as many of them as possible. And then for the ones that's not passing, we need to analyze them and see each whether this is just an output difference or is it more like a correctness issue, right? So we kind of have to label them one by one, and if there are inconsistency between the two, we need to make a call on which one do we go with, right? So this is just a lot of grunt work, but it's necessary before we can consider it, production ready. Once that is completed, I think Rodan in parallel, OXC is also trying to finish the syntax downleveling transforms, like some of the hardest ones are like the async generators and stuff like that. But it's well underway. So I think by end of this year, we're hoping to get Rolldown to beta status and have the transforms also more or less completed. So that's a good milestone to hit. So that also primes the entire toolchain for general testing into Vite itself. So Rolldown-based Vite already has a work in progress branch where we pass over 90% of the tests. Some of the tests that's not passing are actually more or less blocked by like tests like legacy mode, which we're kind of like intentionally punting on because I'm not sure like how many people will still be using legacy mode by the time we actually release the thing as stable. So in a way, like Rolldown Vite is somewhat usable. Like we are actually already able to use it to power VTrust to build the Vite docs, but we want to wait until Rolldown is ready. We have all the transforms ready. Then we have an alpha or / beta release for Rolldown-based Vite and have people test it. So this version of Rolldown-based Vite is strictly just replacing ESBuild and Rollup with Rolldown. So feature equivalence, no, not really many new things. It's mostly like we want to make sure the transition is smooth, frameworks can move over to the new one. So that'll probably also take some time. So in that same process, we do eventually want to move Vite over to a full bundle mode that's entirely powered by Rolldown. As nice as unbundled ESM is for smaller projects, we've run into scaling issues in larger projects, especially when you have, say, more than 3,000 unbundled modules as a dev server. So we believe a fully bundled mode is still necessary. And it also allows us to get rid of some of the issues. For example, optimized depths. It can be completely eliminated. So all your dependencies in your source code will go through the exact same transform pipeline for dev and for production. So consistency will improve greatly. And for the meta frameworks, the one important API for meta frameworks SSR log module / in the new environment API is called like environment.run module, something like that. So internally, it's currently still using a JavaScript-based transform. That will also be replaced by a Rust-based implementation that's exported by Rolldown, so that you'd use the same bundling mechanism for your code running in the browser and running other environments, for example, Node.js SSR. That also gets rid of the configuration needs for SSR externals. So removing optimized apps, removing SSR externals are the two major goals of the full bundle mode, and also greatly improving, page load performance in larger projects. So that's kind of down the road, probably Q2 next year. And we will likely kick off some product development in parallel once we get the Rolldown-based Vite into beta status.
Well, that sounds like a whole mountain of work that you guys have to do. So I wish you guys luck on that.
Yep.
That also wraps it up for our questions for this week's episode. Thanks for coming on, Evan. It was a pleasure to have you back on. And it's exciting to see how much progress both the projects have had and what the new project holds.
Thank you. Pleasure to chat. Yeah.
Yeah, super excited for what y'all do. We've had a few other episodes where we talked to people building infrastructure tooling. We had the biome team on a little while back. We had Charlie Marsh talking about Rough and UV in the Python ecosystem, and this really seems like, of the bets that we've taken in this space, this seems like the one that's like most likely to succeed. In my case, it's always a big bet, but I have a lot of faith in y'all. So really excited to see what you do, and wish you all the best.
Thank you.